right, so today, especially because we only have like 26 minutes probably at this point, we are going to practice systems of equations word problems to try and pay attention for those trapdoors. We're going to start with age problems and then go from there. So, first, oh, come on, stop doing this. I hate you so much. I like copy paste these things in, and for some reason today it's getting mad at me. So when I go to present it, it's not there. Like, all right, so now you're just now it won't show me at all. All right, so apparently we're going to start on this one. So get out your notes, please. We are going to head our notes with. Oh, I didn't put header on here. Sorry, I'm going to start to try to put header on the start slide so you know. It's systems word problems is going to be our header. Like, and you can write systems of equations if you want, but you don't have to. "29th all day long." The sun actually came out today. Happy birthday. Akshay's dad. I can shout him out in the YouTube video. All right, so our first question is gone. Our first question that is there says, because if you can't read that, Michael is 4 times as... Actually, I'm just going to reload the whole show. So there's a saying that an author kind of coined, saying the best laid plans of mice and men often go awry. Meaning, like, it doesn't matter how big or small you are or how good of plans you make, things can still hit the fan, right? So, like, now it looks like we're back, but I'm not going to try anything special. So here's our first situation. Ben is, could be Brandon or Ben, who cares? Ben is 4 times as old as Isan and is also 6 years older. So what have they given us here? Adam, how would we set this up?
I would divide the number that is how much older he is by 3.
Okay, tell me more. What? Why?
Because
I genuinely am just not following you yet, so I'm not quite sure where you're going.
if he's 4 times older than and he has 6 years, and he's 6 years older than Ishan, wouldn't Ishan be 2 and him 4? I mean, not 4, 8.
So let's write a couple things down to be sure about our solution. To write down, now be careful how we say this. It's 4 times as old, which I know you think means the same thing as 4 times older than, but it doesn't. Those are 2 different mathematical statements. So 4 times as old is the multiplication of 4, right? But Ben is, we start with Ben is, right? Ben is always an equals. 4 times as old as Isan, I'll use a capital I. Lowercase I is actually a math value. And then it also says, and is also. So guys, we could write another B equals, or we could just write another equals. They're giving us equal values method. So Ben is 6 years older than Isan. So yeah, Ben is Isan plus. Boy, you said we could also say that I is B minus 6. It might be more convenient to use that. Well, I don't know. I mean, I guess if we look up here, what could we do up here to solve this one? Kelly?
So what you could do is you could take, so you have your 4 times I equals I plus 6. So you can
Absolutely.
And then you can factor that into either of the two, I plus 6 or 4 times I, and get that B equals 8. So to solve this equation, E equals 2 and B is 8.
Now, the thing not to do, because I used to fall into this trap door, so I'm like pointing out the trap I fell into, and I hope you avoid it, is you look right here, and you say, 4i, I can just divide by 4. Except then you get a 4th I, and this would also get kind of messy, so always group up like terms first, right? Always group up like terms first. So here's another situation. We're starting easy, then I promise we will get more complex. Try this on your own. Michael is 4 times as old as Brandon and is also 27 years older than Brandon. Hey, it worked.
What a miracle.
Please make sure that we're taking quality notes in a dedicated spot on graph paper. I'm just going to go around the room. AJ, what could we do first here? You're good. Ben, do you know what we could do first here? Do you know what we could do first here to start solving? You're good. So if we set out the two values that Michael is equal to, Michael's equal to 4b, and he's also equal to b plus 27. Now we could set these as two separate equations. Oh, hey, look, I set them as two separate equations. If I cover up this equal sign, m equals 4b and m equals b plus 27. But if I cover these up, I just got two b equations, and that's kind of what I want. Because then I can solve for b. So again, if I divide by 4, things get messy. Don't do that first. You could. I'm not saying that you can't. I'm just saying it's a bad idea, right? So, and this is like a lot of adults will try to guide you in your life and say like, well, you can do that, but you probably shouldn't. And most of the time, we all have your best interest at heart. I just have your effort in mind, right? I don't want you to put in extra effort. Do you really want to do 27 divided by 4? Not really. However, divided by 3 would be a whole lot nicer.
I'm confused as to why we're going through all the complicated algebra stuff when you can solve it easily with just dividing 27 by 3 immediately, getting that, and then multiplying whatever b is equal to by 4.
So, Adam, you're obviously a bit better at this than the average Joe. We're going through it because not everyone can just get it as quickly as your brain's getting it. You know what I mean? So I mean that as a compliment, that you're doing well at this and you think it's easy. Not everyone does. Does that make sense? So you can zone me out if you want to. You can ignore me if you want to. We're about to go to much more complicated questions. I'm making sure we have the foundational skills here. So, if we set up these equations, we subtract b on both sides, and we get 3b is equal to 27, which now is when we do exactly what Adam's telling us to do, and we divide by that 3. We say b is 27 divided by 3? 9. And if b is 9, we can then plug that back in, up in our m equation, in either of them, really. And m would be 36. So now on to the more complicated questions. Try this, Adam. I will be thoroughly impressed if you can do it in your head. I'm not saying I don't think you can, but these are a lot more challenging. This one's different. Yep, right up by the cubby.
Every time I ask that, and then I look up, and around the room,
Do you get what I mean now, Adam, where this one's a bit more challenging?
I also don't think you heard. I might have misspoken. What I said was I didn't do the last one. I had meant to.
Oh.
I did.
I thought you said did, yeah. I thought you said did.
Quickly wrote it down and then thought for a second.
So, what we practiced right at the end of class yesterday was with the, if they give us a reference point in the past. Now, we could also, like, reference up into the future in yesterday's problem. I don't know if we can reference into the future here because 3 years ago, Ben was 3 times as old as Daniel. I've got a mistake up here. Somebody should point out my mistake. Huh? Oh, negative. What?
you have to subtract 3 from 3 times b.
Ah.
For the, and you have to multiply it. That's what it is.
Yeah. So not only do we have to subtract 3 away, but if D is Daniel's age now, then it's not 3D minus 3. It's 3 times D minus 3. So Ben 3 years ago, Daniel 3 years ago. This is going to multiply to both values unless we get rid of it. But yeah, this distributes. So this is actually B minus 3 equals 3D minus 9. Then we'd be able to say this is really B equals 3D minus 6. And then we could do our equal values method. Right? Because now we've got our other B equals isolated. So grab your other B equals of D equals 20, or sorry, D plus 20. Solve this out. I'm going to do it off camera because I see some people using their hand to hold up their head as opposed to using their hand to do mathematics. Your neck holds up your head. You don't need your hand to do that. Ah, you fell in the trap. They met each other 2 years ago. Doesn't matter at all. 3 years ago, Ben was 3 times as old as Daniel. So 3, hey, don't ask a question, then interrupt the people trying to answer you for a second, okay? Just let me talk, then I'll let you talk. 3 years ago would be Ben's age now minus 3. 3 years ago, Daniel would be Daniel's age now minus 3. Right? So, if the first equation we use uses B and D for now, we got to do B minus 3 for Ben 3 years ago and D minus 3 for Dan 3 years ago. Does that make sense?
Oh, okay.
The 2 years ago is irrelevant. It is a distractor.
I completely used a different method.
Well, it may work out to be the same answer, but it may not.
I used D plus 20 equals D3 minus, or 3D minus 3.
Yeah, that is not true.
Is that true?
That is not true. What you wrote is not true.
Okay.
What have you wrote? Stupid people. We have school going on right now. Do this work outside of... Okay. I'm just going to deep breathe. I know, my students and I are laughing at it.
Just so you know, it's not coming from the office.
Oh, I know. Love you guys too much. I know it's some silly dudes here who shouldn't be working while we have class going.
I repeat, 1, 2, 3, not it. 1, 2, 3, not it.
That's one of the academy teachers. So I'm not advising you to do what I just did, but because I'm using colors, I'm going to group all of my like terms in the same step. So we got to two different expressions for Ben's age, right? Our first expression came from the beginning, that Ben is Daniel plus 20. The second expression that we're using came from our bit of manipulation of the 3 years ago situation. So we now set our 3D minus 6 equal to D plus 20. I need to get my D's together, which will push my D's to the left side, which then means I need to get rid of this constant, so I can do both of those at the same time, or I could do one after the other. If you do both at the same time, be extremely careful. So 20 plus 6, 26. What does D come out to be? 13, because we would divide by 2. Where'd my red go? Divide by 2, divide by 2. All right, so then we're still not done. Take D and plug it in wherever you want to one of the other equations. How old is Ben? 33. I'm closer to that than I want to be. Oh, I'm going to start doing that at the beginning of I didn't remember that Friday classes are only a half hour. This is barely enough time to get anything done, let alone add Khan Academy in with it. So we're going to do that at the beginning of the weeks. One for your own. And I promise I'm actually going to give you time and try to, yeah. The whole thing? Yes, the whole thing. Actually, I shouldn't have said that because doing math in your head is not impressive to me. I'm impressed at your calculation abilities, but eventually that falls apart when the math gets tough and you just should write things down. We should get in the habit of write things down. Ignore the part that doesn't matter. Math now starts to like to throw things at you that doesn't matter. Yeah.
So, at the bottom, no, wait. Now we can't make that something. Or, no, can I ask her?
Sure.
Okay, so 14 years ago, Isaiah was 3 times older as Christopher. So I just subtract 14 from Christopher, and I said that, correct? Because they were both 14 years younger.
Yeah, so from your C variable needs to become C minus 14. From your I variable needs to become the expression I minus 14. Because C and I are referencing their ages currently, unless we flip this whole thing around and reference their ages in the past, and then we would need C plus 14 and I plus 14. Now, this one is super tricky with how we write it. Not the first part. Christopher is 20 years younger than Isan. Probably not that hard to write. I'm pretty sure that should be C equals I minus 20. But the second part where it says 14 years ago, Isan was 3 times as old as Christopher. Guys, when I started to write this, I was writing down a reference of Christopher, right? C minus 14, and then I was like, wait, they're telling me Isan was 3 times Christopher, right? So this C minus 14 is Chris's age in the past. And Isan's actually older, right? Because they say Isan is, in the past, right, or Isan was, 3 times as old as Christopher. So the 3 goes over on Christopher's side, actually, because Isan was triple Christopher's age. You're making a face.
I got something, I'm not sure if it's right,
Well, I don't have an answer yet.
yeah, and it confuses me very much.
Does what I have written down so far confuse you, or just what you got now? Let's see if we get the same answer. Because there are multiple ways to write this out and do this. And because like I could also write Isan is Christopher plus 20. If you wanted to, right? Because Isan is 20 years older than Christopher, or Christopher is Isan's age minus 20, right? So there are other options always of what we can use. So if I start working my equation from the past, sorry, I gave you guys a head start, so I hope you're not mad at me for solving it now. If I do so extremely carefully, I can group all my like terms at the same time. Get rid of the I. Wait. Crap. Get rid of the I. I don't have another I over here. We could either substitute in a C or substitute in an I, because we have these two different expressions that mean the same thing. Love it. So sub in the I is the idea given to me, so I'm going to follow that idea. So don't do that. This is why you should not write in pen. Substitute the I. So when you hit one of those like, wait a minute, ask yourself what other options do we have, right? Substitution is always an option. So now we're going to have 3C minus 42 equal to, instead of I'm now writing C plus 20 minus 14. Question?
I was going to say, another method you could do is add 14 to both sides previous to that and get I equals 3C minus 28. Then you don't have to add minus 14. It eliminates a step. Well, I mean, it doesn't eliminate a step. It just can be simpler.
So if we did it like that, then we can set the other I equal to it. Absolutely, you're right.
So then you don't have to add or subtract anything.
I was about to say that's this, right?
It's going to add 14 right now.
Absolutely.
So
So I don't know why I left this big gap here, but I did. So it is what it is. Yeah, now is where if we are super careful. Nah, I'm not going to do the gotta be super careful because I forgot to do it. I'm just going to do it in two different steps. I don't know what color to use.
well, that's interesting.
2C equals 48. So Chris, I think, is 24.
Yeah, I totally messed up my version. I wrote
That's very different. I was right to be confused by my answer.
Something go awry? Something with your setup?
I got C equals 2 and I equals 8. So the same answer as the first question.
See where I was saying that your method gets dangerous as the problems get trickier? Like the whole mental manipulation gets harder as we get more layers of information. If C is 24, then Isaiah is 20 years more than that. Or, sorry, whoever, Isan? I forget what the name was.
Eshon. The names are the same.
We have 2 minutes left if you want to challenge yourself and try another. Alright, so now the situations where instead of just age type problems, we have two separate variables, such as economy and business class seats. So, in situations like this, where it says a plane has 360 seats total, what would we set up from like 360 total? What should we build? What equation should we write from that sentence? I would use E and B. I would use economy and business, right? Because they tell us that 360 seats are economy and business. Then, for every 13 seats in economy, there are 5 seats in business. This is going to get complicated. So this we're going to stop for today. I think because it's at the end of the bucket, and they just got replaced like 2 days ago. I go through a lot because I teach 5 classes. I will tell you, there starts to become kind of like a proportional relationship situation here. So if you look at, for every 13 seats in economy, there are 5 seats in business. You should be able to set up that relationship of if business is 5, then economy is 13. If business is 10, economy is 26, right? You could graph it. It's a proportional relationship.
And then you could set E to, I would set E to X, E to the X value.
Yeah. Lots of ways to solve it. All right, to your extensions rooms, guys. Quit grouping up at the door. That is the opposite of what we're trying for.